This is Chemical Reactions Part 1. I want you to watch this video and write the notes in your notebook. When you finish, go to Show My Homework and answer the quiz questions. Very short quiz questions. Okay, you're going to be learning about chemical reactions and different types of chemical reactions. So what is a chemical reaction? It is a change that makes a new substance. Now, you will see word equations or chemical equations, and whatever is written on the left side, that is the reactants. Okay, so the reactants are the original substances that change into products. So in this case, we have ammonia and hydrochloric acid as reactants. Now they are going to go through a chemical reaction to make a new product. The product in this case is ammonium chloride, NH4Cl. You can have more than one product. It's any new substance or substances that are made, and they're always written on the right side. Now, in a chemical reaction, matter cannot be destroyed. And what that means is the same number of atoms are on both sides. If you were to count the nitrogen on the reactant side, you get 1, and there's also 1 nitrogen on the product side. There are 4 hydrogen on the reactant side and 4 hydrogen on the product side, and there's 1 chlorine atom and 1 chlorine atom. So this is equal and balanced. Now if I'm going too fast, pause and make sure you get all of this written down. Okay. In a chemical reaction, energy is released or it is absorbed. Now I put in parentheses what those two words mean if you don't know already. An exothermic reaction is a reaction that releases heat. So you see the two glow sticks, and if you crack them, there's 2 liquids inside. They will mix. A chemical reaction will happen. They'll give off heat and light as energy, and that is called an exothermic reaction. Now there's another type of thermic reaction called endothermic, and that's a reaction that absorbs heat. So you see the picture, and the person has sprained their ankle, and they have a cooling pack that has 2 chemicals in it. You crack the chemicals and they mix, and they create a reaction that absorbs it, takes energy, heat energy in. So this is going to take heat away from the swelling in the sprained ankle. Alright, so we have 3 different types of reactions that you're going to learn about today. Number 1 is a neutralization reaction, and neutralization reactions make salts. A neutralization reaction is when an alkali, a base, and an acid combine to make a salt, and they also make water. Okay. A salt is a substance formed in a neutralization reaction. And there's a nice picture of salt crystals. Now I need you to remember the pH scale. If we're going to talk about neutralization reactions and acids and alkalis, you need to remember that on the pH scale, 1 to 6.9 is an acid, and 7.1 going all the way up to 14 is an alkali, also called a base. Now these are liquids, so they're solutions, and when they are mixed together, you can get a pH number, which will tell you the acidity. And as the 2 substances or 2 solutions are mixed together, the pH number will get closer to 7. In a neutralization reaction, we want to get a pH of 7. Okay, strongly acidic solutions are pH 1, and strongly alkaline solutions are pH 14. So here is our general word equation for a neutralization reaction. It is an acid plus an alkali will make, the arrow means make or yield, give us salt plus water. So some alkalis are metal hydroxide. Sodium hydroxide is a strong alkali. It's one of the most common, and it's what you will probably know. It is a drain cleaner, and if you look at the picture, that's sodium hydroxide as a crystal, and the Thai word for this is sansone. So when you get a clog in your drain in your bathroom or your kitchen sink, you can use sandstone and water and it will dissolve. It will eat away whatever is clogged up the drain. Now another strong alkali is potassium hydroxide, which is in wood cleaner, and other examples include lithium hydroxide, copper hydroxide, aluminum hydroxide, and iron hydroxide. And so this is sandstone, NaOH. Acid plus alkali makes salt plus water. Okay, so here's a word equation for neutralization. Sodium hydroxide plus hydrochloric acid makes sodium chloride plus water. Here, side by side, a neutral solution. If you leave a neutral solution to evaporate, you will see that salt crystals are formed, and many of these salt crystals can be used. There's a commercial salt production picture where man-made lakes are used. They're flooded with seawater, and then the sun's heat energy evaporates the water off, leaving the salt behind. And then there's also a picture of the same thing in the lab. So, naming the salt. You don't have to write this down. I have included it in your lab sheet that you'll be getting when you go to lab 1. The first part of the name of the metal is from the alkali. The first part is the name of the metal from the alkali. Sorry, excuse me. So you don't change the metal, you just rewrite it when you're coming up with the name for the salt. The second part, the second part is from the acid. So hydrochloric acid makes chloride salts, sodium chloride, NaCl. Sulfuric acid makes sulfate salts, magnesium sulfate, MgSO4. Nitric acid makes nitrate salts, potassium nitrate, or KNO3. Corrosion. We should know this. We should know the symbol from lab safety. Corrosion is the eating away of a surface of a solid in a chemical reaction. Now, strong acids and strong alkalis are corrosive. Okay? So now we're going to talk about our second type of reaction. This is number 2, acids and metals. And you will see a picture there of a couple different types of metal, magnesium, zinc, iron, and lead being mixed with an acid. So here's another picture of different metals. You know this already. Iron, lead, magnesium, copper, and zinc, all very common metals. Okay, in the lab there are 3 acids that we use. Hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. Got to know these 3. Okay, an acid and a metal reaction make 2 products. So in the picture you see magnesium strip of metal, and it's got a dilute acid, and there's bubbles of gas rising to the surface. So what type of gas is this? Well, this is hydrogen gas. So you see bubbles. That's the first product. How do we know it's hydrogen? Well, from the apparatus that's set up on the left-hand side, there is dilute sulfuric acid and zinc, and it's producing hydrogen gas, and there's a tube that has bubbles coming out of it and a candle, and there's a little explosion. So what we do is we trap the gas, and we use a lighted wooden splint. Now, a lighted splint is a match. Okay? And hydrogen gas makes a squeaky pop when you test it with a match. So that is something to remember. Squeaky pop. Hydrogen gas makes a squeaky pop when you test it with a match. Alright, acid and metal reactions make 2 products. The second product is a salt. And this is zinc sulfate, ZnSO4. So this is the general word equation for an acid and metal reaction. Acid plus metal makes salt plus hydrogen. And the salt that is made depends on the acid. So again, hydrochloric acid makes chlorides, sulfuric acid makes sulfates, And nitric acid makes nitrate salts. These are all salts. And there's a picture of nickel sulfate, sodium chloride, copper sulfate, cobalt nitrate, and iron chloride, all metal salts. And just a quick review of some very common acid and metal chemical reactions. Magnesium plus sulfuric acid makes magnesium sulfate plus hydrogen. And I'll skip down to the bottom. The fourth one, iron plus hydrochloric acid makes iron chloride plus hydrogen. And notice in all four of these that hydrogen is a product. Okay, and that will take us over to our third type of reaction, our last reaction for the day. This is number 3, acids and carbonates. So, examples of calcium carbonate. Now, calcium carbonate is probably the most common, it is the most common carbonate found throughout the world. So, limestone, marble, and chalk are made from calcium carbonate. And then when there's 6 pictures there, you see coral from the ocean floor. Coral and seashells are made from calcium carbonate. There is some bricks made from limestone, stalactites and stalagmites in a cave, calcium carbonate, limestone. The white cliffs of Dover from the coast of England, in Dover, they're chalk formations. And you see eggshells. Eggshells are made of calcium carbonate, and again, colored chalk, calcium carbonate. So, there are 3 carbonate compounds that you need to remember. These are sodium carbonate, calcium carbonate, and magnesium carbonate. The metal comes first, the carbonate comes second, and the chemical formula for the ending, the carbonate, is CO3. Okay, metal carbonates neutralize acids, making a salt, water, and carbon dioxide gas. So, this is a neutralization reaction from our first type, but it's a specific one. With this reaction, acids and carbonates, you get 3 products. 3 products: salt, water, and carbon dioxide. So in this case, if you have a stomach ache, you can take a calcium carbonate tablet that will react with the hydrochloric acid that's being produced by your body in your stomach, and the acid will be neutralized, and you'll feel better. Okay, now also, acid rain. Acid rain is a problem that's become more prevalent in the last few decades. But it is common, naturally occurring. Acid rain has, the levels of acid rain have increased with auto emissions and industrialization and the harmful gases, especially carbon dioxide, that are given off from factories. So what happens here? Well, acid rain, you have carbonic acid and nitric acid in the air in the atmosphere. Also, volcanoes are a natural cause of these types of acids, these types of compounds. They react with water during a rainstorm. They make an acid, and when they come in contact with limestone or marble statues, they will start to react with the calcium carbonate in those 2 stones, and the building will start to deteriorate, or the statue will start to break down. And you can see the side-by-side picture before and after. This statue no longer has a face. So it's an issue. It's something to be concerned about, that we have to deal with, and it's something common that happens in our everyday experiences. Okay. Metal carbonate plus acid makes salt plus water plus carbon dioxide. So this is the word equation, the general word equation. We can test for carbon dioxide using a substance called lime water, a solution called lime water. And that's basically water with very dilute powdered calcium carbonate. And it reacts with the carbon dioxide, forming a cloudy mixture. And you can see in the picture what was clear white acid has turned very cloudy when it was given some lime water. We'll be doing this in lab. Okay. Again, the acids that we're going to be using in lab: hydrochloric acid, sulfuric acid, and nitric acid. And acid and carbonate reactions make 3 products. Here's a picture of calcium chloride. Okay. What are these 3 products? I've already said them. 1 is salt. 2, carbon dioxide. You see the bubbles. It turns lime water solution cloudy or milky. And the 3rd is water, H2O. So, just a quick review of some word equations. Oh, we got another slide here. How do we know it is carbon dioxide? Lime water is an indicator for carbon dioxide. It turns cloudy or milky when carbon dioxide is added. Okay. And another thing to remember, we've already gone over this. The acid used will determine what metal salt will be made. Okay. So we're going to try and complete some word equations. If you look at the first one, it says sodium carbonate, and then there's an orange box with a question mark. Makes sodium nitrate plus something and water. Well, we know that this is metal carbonate, sodium carbonate, and it's going to react with an acid. And we can look at the ending of the metal salt that it is made on the product side, which is nitrate. And so this will tell me that it's one of the 3 acids. It has to be one of the 3 acids. So it's nitric acid because it makes nitrate, a metal salt that ends with nitrate. And our 3 products are metal salt and carbon dioxide and water. Nitric acid and carbon dioxide. Okay, going to the second one. We have some type of carbonate that's going to be added with nitric acid, which makes calcium nitrate, carbon dioxide, and water. So when I go to the metal salt, I know that the first part is a metal, calcium, and I know that this is a carbonate reaction because of the carbon dioxide and water and metal salt that's produced. So this must be calcium carbonate, and it is. Okay, and the last one, zinc carbonate plus sulfuric acid is going to make what? What's the metal? The metal comes from zinc carbonate. What's the metal? What's the metal? The metal is zinc. And what's the acid? It's sulfuric acid. So sulfuric acid is going to make a metal salt that ends with sulfate. So zinc sulfate. And I know that the other ones are carbon dioxide and water. Okay. Chemical reaction CaCO3 plus HCl. What is calcium carbonate and hydrochloric acid going to make? It's going to make calcium chloride, carbon dioxide, and water. Yes. And one last thing to remember, lime water is an indicator. What do we use it to test for? We used it to test for carbon dioxide. Alright guys, that's one of our labs that we're going to be doing. And we'll be going on to chemical reactions part 2 next week. So, thank you for hanging in there with me. This was a little under 20 minutes. And go over to Show My Homework and answer the quick quiz questions. I'll see you in lab. Have a great day.